In this video, we'll discuss and explore some of the important factors that can affect or impact overall design decisions when we're developing or implementing a distributed data warehouse. We'll begin by exploring some of the essential or important factors that we need to consider when we're deploying or designing our data warehouses. The first important factor is the process selection. It essentially indicates the operational or strategic part of the process that are required to gain insights of an enterprise. Identifying the process that are supported by data warehouses for application insights becomes one of the essential characteristics or factors that we need to consider while designing data warehouses. The second important factor is the identification of data or information granularity. Granularity depends on the types of reports and queries that we'll be generating in order to benefit the users of our data warehouses. Next, we need to define the dimensions and facts. Dimensions and facts will help us properly model the data in order to depict the right granularity of the data within the tables, using various modeling approaches like snowflakes and star schemas. The tables can either be fact or dimensions. The last important factor is the data retaining duration, which is basically the duration of the usefulness of the data. We need to plan time series properly and identify the factors that make the availability and duration of the data impactful for various analytical requirements. Now, apart from the various design factors that we discussed earlier, there are a few other considerations of table combination for dimension modeling that we need to be aware of. The first important element that we have to consider while designing our table combination for dimensional modeling is query. The table combination should be query-centric, as query essentially provides the outcome, and our design or model should be appropriate for query execution. Data accessibility is another element that we have to focus on, and depending on the varying user group, we need to ensure that the data is made accessible to all of them. Data warehouse typically is meant for analytics, and as such, we need to ensure that the dimensional models are optimized for analysis. Apart from the analytical optimization, we also need to focus on how the dimensions and facts will interact with each other, so they can provide valuable or meaningful outcome when we execute queries. Finally, the table combinations must also support drill-down or roll-up features, so they can serve the varying reports and report classification required by the enterprise to predict or to make important decisions. Now let's quickly explore a table scenario using the sample figure to understand what we've discussed better. The sample figure illustrates a table which is titled Medical Measures. This particular table is the central table which contains the fact, and using this particular fact, we can derive various dimensions. For example, medicine is a dimension of treatment, and admit date is another dimension of treatment, which captures the attributes of date, so we can identify when the patient was treated. All the treatments will be facilitated for the patients, so we'll be creating another dimension for treatment measures, in this case, the patients, so we can maintain all the attributes of the patient. Apart from this, we'll need another table for the nurses, who are responsible for admitting the patients for treatment. So we'll be creating another dimension to track who admitted a particular patient, the data and details of treatment, and all the medicines that were prescribed as a part of the treatment. We can even maintain various other information in the fact table, for example, the expected cost of the treatment and the number of patients treated. And all these fact and dimension tables will be linked with each other using the concept of referential integrity. There are certain factors attributed to business performance that can impact or affect the design of the data warehouses. Let's quickly explore some of the important business factors that can impact or affect the data warehouse design. The first important business factor is the revenue growth pattern of a business. We need to understand the revenue growth pattern of a business and factor them into our data warehouse designs. Then there's profitability analysis. The data warehouse should be capable of performing profitability analysis, and this has to be factored into our data warehouses. Using the market data, our data warehouse should be able to capture and visualize the trend of market growth. We also need to align our data warehouses and the analytical outcomes with the business strategy. This can have major impact on our data warehouse design as well. And finally, we should provision analytical capabilities to our data warehouses so we can identify the expected return on investment from our data warehouse implementations. So these are some of the essential factors revolving around the dimensional modeling approaches and business aspects that can impact the overall design of our data warehouses.